Hi, where are you watching from? Drop your city and country in the comments.
The air inside the monolithic titanium-reinforced control bunker of Vacuum Transit Sector 7 was maintained under a strict, hyper-filtered state of triple-stage compression, an artificial environment engineered to be completely free of atmospheric humidity, industrial condensation, or the microscale carbon dust generated by high-velocity magnetic braking grids. It carried the sharp, dry smell of clean nitrogen gas, ionized static fields, and the cold, synthetic scent of fluorinated coolant vapor that kept the linear induction stators from melting under full structural load. From a triple-glazed, armor-plated observation portal, the active transit tube looked like a seamless, white steel pipe 5 meters in diameter, stretching deep into the mountain bedrock, wrapped in heavy structural dampening collars that hummed with a low, terrifying acoustic vibration. The subterranean floor beneath my feet did not merely shake. It produced a continuous, ultra-low frequency resonance that vibrated through my work boots. The unmistakable mechanical feedback of an iron mass sliding through a near vacuum at 900 kilometers per hour. I sat on a low, steel-welded equipment trunk near the secondary pressure equalization manifold, my heavy canvas inspection jacket, thick, discolored by old streaks of vacuum seal polymers and bearing the faint chemical burns of hydraulic fluid leaks, resting loosely across my lap. For 43 years, my official title within the National High-Speed Transit Security and Subsurface Aerodynamics Agency had been Chief Gas Dynamic Arbitrator and Senior Transonic Flow Analyst. In the slick, computer-animated marketing videos released by the Corporate Logistics Board of the Modern Transport Infrastructure Syndicate, my deep-level validation station was viewed as an expensive, slow-moving administrative relic from the early, subsonic rail era. The new private transit operator, AeroVanguard Kinetic Systems, had long since transitioned to using automated laser diode pressure sensors, electronic acoustic boundary wave microtransducers, and cloud-based molecular fluid simulation software that treated an unstable, high-velocity air column compression zone at -50 degrees as a simple, predictable blue line moving across an executive screen. They genuinely believed that carrying 20 tons of commercial payload through an evacuated underground concrete sleeve was nothing more than a matter of selecting an automated speed profile on a sleek digital dashboard and letting automated vacuum gates handle the pressure balancing. But automated boundary sensors do not calculate the microscopic physical distortion that occurs inside an aluminum expansion joint when a sudden thermal gradient forces a high-pressure air pocket to bypass the vacuum cell casquettes. They don't hear the tiny, ultra-high-frequency metallic pinging sound inside a magnetic suspension housing that indicates the structural support pillar is beginning to flex under a localized sonic boom long before any volumetric pressure variance registers on a remote terminal bank. I was the man who knew the exact aerodynamic weight of a compressed air column moving inside a restricted space, the precise acoustic pitch of a stable shock wavefront, and exactly how many fractions of a millimeter a forward compressor blade could deflect before the phenomenon of aerodynamic choking would freeze the transit capsule's bypass airflow, turning the entire steel transport tube into a self-destructive pneumatic ram. I was not a transport investment director, an infrastructure efficiency manager, or a digital software engineer. I was a physical reader of gas velocity, wave boundaries, and structural pressure who had spent half his life walking the dark concrete maintenance alcoves of deep-level vacuum lines, reading the invisible, explosive structural warnings that the automated telemetry systems were too uncalibrated to detect. My cousin's son, Raymond, stood near the primary variable frequency magnet control console, his spotless, high-visibility white executive jacket carrying the crisp, synthetic smell of a corporate boardroom as he verified a digital transit schedule on his tablet. He was 36, the regional managing director of infrastructure velocity compression for AeroVanguard, a man whose entire professional career was built entirely around transit corridor optimization, which in practical terms meant reducing the mandatory 48-hour vacuum tube stabilization and thermal cooling sequence to 12 minutes, forcing high-velocity capsules to run past their critical shockwave thresholds to clear the terminal bays faster and threatening veteran line. Technicians with immediate termination if they delayed a commercial cargo run due to micro-vacuum alerts. The automated aerodynamic certification from our central network is already cleared and logged into the Federal Transit Asset Ledger. Uncle Arthur, Raymond said, his voice holding the rapid, clipped tempo of an executive whose stock performance was directly tied to clearing the high-speed cargo route before the regional logistics conglomerate's financial quarter closed. Our downhole digital arrays check the residual air density across 5,000 independent sectors along the mountain bypass line. The wave resistance curve is completely flat. The system is operating at maximum kinetic efficiency. Honestly, at 82, walking the lower vacuum alcoves with a manual acoustic bar and an old mechanical pressure cup just to check the casing seals is an unnecessary physical liability. You're slowing down the network velocity. He was framing my systematic removal from the high-speed aerodynamic management team not as a cold corporate firing, but as a compassionate, protective retirement plan designed to save my aging joints from the freezing tunnel drafts. This is the precise, clinical script of modern institutional liquidation. You never tell a master gas dynamic engineer that his ears can read the structural stability of a supersonic wave front more accurately than your uncalibrated software simulations. You tell him he is too fragile for the dark. The downhole digital sensors only read the light absorption inside the clear monitoring windows, Raymond. I said, my voice low, holding the flat, gravelly weight of a man who spent 40 years speaking over the deafening scream of 20,000 horsepower vacuum displacement turbines. The computer doesn't see the air pocket migrating behind the main expansion joint near the lower mountain gate. The shockwave simulation model was engineered by the leading aerospace aerodynamics group in Tokyo. Arthur, he replied, sliding his tablet into his leather folder with a swift, aggressive motion. We don't need an old tunnel master using an analog dial to tell us if a vacuum seal is maintaining its boundary. We are on a 24-hour countdown to initiate the full-velocity commercial transit phase for the Aero 7 heavy cargo capsule before the global shipping window locks. My corporate partners and I have already finalized your housing package at the Emerald Crest Sanctuary. It's an exclusive luxury community in the Southern Hills with its own climate-controlled glass sunrooms, private paths, and total isolation from industrial utility sectors. What Raymond completely left out of his fast-paced corporate summary was the fact that his advancement to Senior Vice President of Continental Logistics was entirely dependent on clearing the deep-level transit route before the end of the fiscal month, and that his private syndicate had already negotiated to lease the vacuum maintenance rights back to the state at a 600% premium the moment my regulatory inspection office was dismantled. The structural friction between my physical experience in the alcoves and my nephew's digital velocity schedule reached a dangerous limit exactly 12 days later, during the production launch of the main Transit Conduit 7 Alpha. The infrastructure component was a massive 20-kilometer segment of thick-walled steel tube designed to handle a vacuum pressure of less than 100 pascals while carrying multi-ton magnetic levitation capsules under extreme velocity from the mountain terminal straight to the valley shipping hubs. To the regional transport office, it was a high-value utility asset that needed to be brought up to full operating speed within 8 hours to avoid a severe non-compliance fine from the logistics network. To Raymond, it was the final physical benchmark that needed to be verified before the corporate directors arrived for the public ribbon-cutting ceremony at the transit line's new automated lower-level loading wing. He came down to the cold concrete pad of Sector 7 during a heavy, freezing Thursday afternoon sleet storm, his thin-soled dress shoes getting instantly coated in gray mud near the high-pressure vacuum valves. He was accompanied by a man named Sterling, the newly appointed Commissioner of High-Speed Regional Transit Compliance, a 34-year-old political operative whose knowledge of fluid dynamics was entirely limited to what he had skimmed from the executive summary of the state infrastructure development budget. Mr. Thorne, Sterling said, his face pale as he gripped his umbrella while the cold mountain rain swept across the concrete pad. We've reviewed the electronic readouts from the tube's primary vacuum sensors. The internal telemetry shows zero pressure fluctuations along the primary transit segment. We need you to sign the formal aerodynamic clearance certificate so the technicians can pull the manual isolation clamps and let the automated system ramp the linear induction motors up to full capacity. He reached out a leather-bound folder with a digital tablet fixed inside, a legal document that would completely clear Aero Vanguard of any engineering liability if the high-velocity capsule caused a structural materials failure or destroyed the vacuum tube infrastructure. The digital sensors are reading the gas velocity inside the smooth center of the line. "Mr. Sterling," I said, keeping my hands buried inside the thick, grease-stained pockets of my canvas inspector's coat. "They aren't reading the static pressure building up behind the secondary bypass filtration screen. The weather outside isn't the problem. The internal wave friction is." Raymond stepped directly into the gap between me and the compliance commissioner, his teeth grinding with frustration, his voice rising to a shout to be heard over the high-pitched, mechanical whine of the massive vacuum displacement turbines. "Arthur, let's end this old-timer folklore routine right now. The loading software calculates wave friction and tube expansion automatically based on air density. Every hour this capsule remains throttled back costs the syndicate $90,000 in delayed delivery penalties. Your refusal to sign this certificate is a direct breach of your regulatory mandate. If that screen isn't touched by 5 o'clock, Sterling and I will initiate an emergency administrative override under the High-Speed Transit Fast Track Act." He stepped closer, his face inches from mine, his eyes wild with a cold, financial desperation that contained no trace of family loyalty. "We know what this is about, old man. You're terrified that this entire complex is going to run on automated switches without your signature on a piece of paper. But your era is dead. If you don't clear this line, we will have facility security escort you off the well site for domestic obstruction, and your state pension's premium medical fund will be frozen pending an immediate compliance review." He leaned in until the cold rain from his hard hat dripped onto my collar. "The Emerald Crest Sanctuary doesn't take residence with an open state investigation, Arthur. You'll be spending your winter in a state-run tenement down by the industrial docks where the tap water smells like sulfur and the floor vibrates every time a waste barge pulls in. Sign the clearance and let the motors roll." The final confrontation did not take place in the rain of the loading pad. It occurred 48 hours later inside the ultra-modern, glass-walled conference suite of the International Transit Risk Underwriters Group on the 74th floor of the Continental Tower, a building that looked down onto the city harbor like a concrete fortress. Raymond had arranged an emergency technical arbitration hearing, using an unmarked corporate vehicle to transport me there as if I were a piece of non-functional laboratory equipment being brought before a panel of corporate bankruptcy referees. Chairman Geller, the senior risk underwriter whose global fund had guaranteed $400 million against the completion of the Sector 7 transit corridor, sat at the head of the long obsidian table. Next to him sat Raymond, his laptop open to a high-fidelity gas dynamic simulation titled Project Kinetic, Transonic Flow Optimization, and Commissioner Sterling, who was quietly reviewing a stack of pre-signed environmental waivers. "Mr. Thorne," Chairman Geller began, his voice low, dry, and entirely devoid of human inflection, the voice of a man who measured the world solely in risk-adjusted capital returns. "Your nephew has provided this panel with an exhaustive, data-driven analysis of the Sector 7 vacuum curve. The digital metrics indicate that the internal gas density is entirely stable and capable of handling the maximum velocity profile. Your continued refusal to sign off on the aerodynamic clearance appears to be based on personal stubbornness rather than any measurable engineering reality." The monitor on the obsidian wall flashed an animated loop of the transit line, showing the high-speed capsule moving smoothly through blue digital channels into the mountain tunnel, the interface glowing with a bright, comforting green that indicated zero risk of structural failure. "The simulation is running on an idealized static model, Chairman," I said, standing up from my seat without using the armrests. I didn't reach for a USB drive. Instead, I reached into my clean rigger's bag and placed 3 separate steel bypass blades onto the polished surface of the table. Each blade was 2 feet long, its hard titanium edge completely scarred, discolored, and warped into a jagged, wave-like distortion pattern by high-velocity friction heat. In November of 1997, I said, my voice cutting through the room's silent air conditioning with the absolute authority of an old tunnel master's voice. The sister system of this project, the Transit Line 3 vacuum sleeve, attempted to move a cargo mass under identical high-velocity parameters. The company computers at the time stated the internal expansion joints were perfectly free of structural impurities. But the computers didn't calculate what happens when a deep-level structural alignment shifts by a fraction of a millimeter over a 9-month operation cycle, introducing a micro-obstacle into a supersonic airflow. Raymond slammed his hand onto the table, the glass cups rattling against the granite trim. The 1997 incident used early first-generation mechanical guide shoes, Arthur. Sector 7 uses an advanced active magnetic stabilization track that operates completely without physical contact. The track operates without physical contact, Raymond, I replied, looking directly at Chairman Geller, whose eyes had shifted from the simulation screen down to the warped titanium bypass blades on the table. Your maintenance crew didn't realize that the thermal expansion during the test run last Tuesday morning didn't just clear the tube. It introduced a micro-buckling event along the lower steel wall 3 kilometers deep down the mountain. That wave distortion on the blade edge isn't standard wear. It's the result of an aerodynamic choking boundary event. Your automated system is reading the tube pressure as stable because the capsule hasn't entered the restricted sector yet. It's not a balanced vacuum line. It's a 20-kilometer explosive cannon. I pointed out the window toward the gray outline of the mountain range in the distance. Right now, the air density leaking behind that compromised expansion joint is creating an invisible shockwave barrier as the residual air column is compressed by the capsule's forward face. Because your sensors are calibrated to read gas pressure at the center of the tube rather than wave-induced heat along the pipe borders, your software thinks the velocity profile is safe. The moment you pull those manual safety clamps to increase the motor frequency for the final hot run sequence, that high-velocity compression won't just move the pod. It will initiate an aerodynamic choking shock wave against that air barrier. The resulting acoustic detonation won't just rupture a joint. It will shatter the entire mountain tunnel structure, destroying the Aero 7 capsule on its tracks and flattening every building within a 2-mile perimeter. In the mechanics of high-speed vacuum gas dynamics, there is an absolute physical boundary known as the critical aerodynamic choking threshold, the exact limit beyond which the compression of a restricted air column will spontaneously generate a solid thermal shock wave, turning a low-pressure transport tube into an immovable, solid block of compressed air that cannot be penetrated by any amount of kinetic force. It is a mathematical reality that cannot be negotiated by an executive vote, amended by a transport utility commissioner, or hidden behind a corporate spreadsheet. I pulled a small, clean black ledger from my inside pocket, the original 1997 high-speed aerodynamic disaster and Transonic safety registry, certified by the Federal Bureau of Transportation Safety and bearing the permanent restrictive red-stamped shockwave exclusion number 918 boundary. It was a physical document that existed entirely outside the company's cloud infrastructure, an original regulatory safety mandate that could not be wiped by a system update or bypassed by a state fast-track development waiver. Under Chapter 12 of the Federal High-Speed Transit Safety Code, I said, placing the ledger directly over Raymond's laptop keyboard, any evacuated transport system that exhibits evidence of expansion, joint buckling, or boundary wave choke events must immediately enter a mandatory technical lockdown. The line must be vented to full atmospheric pressure. The automated induction motors are frozen by operation of federal law, and the transit clearance is suspended until a physical laser alignment validation can be performed by a licensed federal inspector. The boardroom became completely silent, save for the faint, high-altitude creak of the glass wall as a fresh wind gust hit the building. Chairman Geller leaned forward, his eyes locking onto the federal red stamp on the canvas cover. He looked up at Sterling, his voice dropping into a razor-thin whisper that signaled the immediate end of his professional patience. Is this safety exclusion active in the Transit Regulatory Archive, Commissioner? Geller asked. Did your department approve a transit fast track that violates a federal shockwave boundary mandate? Sterling's hand shook as he reached for his glasses, his face turning an ashen, translucent white as he tried to navigate a regulatory database on his phone that he didn't know how to search. The digital infrastructure portal doesn't show the pre-2000 subsurface material exclusion acts. We assumed those restrictions were resolved during the digital data migration sweep of 2012. The physical laws of gas dynamics aren't subject to your data migrations, Sterling, I said, taking my manual back from the table. If your operator pulls those manual clamps tonight before the system is vented and realigned, the shockwave friction will rupture the tube before the capsule can clear the first sector. You won't be setting a speed record. You'll be reading the obituary of every technician sitting in that control bunker when the tunnel detonates. Chairman Geller stood up, his face completely expressionless, but his voice carrying the finality of a court judgment. The insurance clearance for the Aero Vanguard project is formally revoked, effective immediately. Freeze the launching sequence. Get the maintenance crews back into the alcoves and vent the tube before the line undergoes a wave collapse. Raymond sat frozen by his chair, his laptop screen reflecting a series of automated warning notifications that his software was finally starting to generate as the localized wave heat along the tube borders began to register outside normal operational limits. Uncle Arthur, you old lunatic, you've ruined us. The Transit Syndicate, they will call the primary manufacturing bonds tomorrow morning. We've already leveraged our entire corporate capital account against the completion timeline. If that certificate is frozen, we're completely bankrupt by Friday. I didn't leverage your capital against a compromised vacuum sleeve, Raymond. Your own arrogance did, I said, packing my titanium bypass blades back into my rigger's bag. You thought that because an old analyst had gray hair on his head, his memory was dead and his logbooks were garbage. But an analyst's job is to read the reality of the material, not the profit of the developer. The collapse of Aero Vanguard kinetic systems was not a gradual decline. It was a sudden, vertical liquidation that erased the company from the National Transport Registry within 90 days. The International Logistics Consortium and the National Transit Development Board withdrew their $400 million financing agreements within 48 hours of a federal engineering team confirming the extensive expansion, joint buckling, and wave deformation along the Sector 7 transit line. The cost of running an emergency tube vent, laser realigning the 20-kilometer steel sleeve, and rebuilding the magnetic suspension blocks exceeded $55 million, a capital expenditure that made the entire high-speed infrastructure project completely unprofitable. Without the expected completion bonus to clear his secondary credit lines, Raymond's partnership filed for Chapter 7 liquidation before the winter snow had closed the mountain transport routes. I was not moved to the Emerald Crest Sanctuary. The Transit Council quietly canceled my retirement notice the following Monday afternoon. They realized that without my specific physical understanding of gas dynamic boundaries and the undigitized shockwave exclusions, they couldn't certify a single high-speed facility in the transit division without risking a structural explosion that would void their municipal insurance policy. They created a permanent position for me, Chief Aerodynamic Integrity Arbitrator and High Vacuum Systems Custodian for the Transit District. My salary is now paid directly out of the nation's core emergency infrastructure account, more than enough to keep my office warm through the winter storms without ever needing to look at a corporate senior community brochure. I still sit on my high steel stool in the control room of Sector 7, watching the digital telemetry lines flicker on the automated sensor screens below. The vacuum conduits operate under my supervision now, their gas dynamic boundaries cross-checked every morning against my manual barographs, and the high-speed capsules leave the terminal at a slow, measured pace, their transit velocity kept strictly below the critical threshold until the internal wavefront has found its perfect, permanent balance within the sleeve. The younger generation operates under the dangerous, modern delusion that technology is the same thing as control, and that a three-dimensional animation can force the fluid to ignore the laws of physics. They believe that success is a matter of simply accelerating the schedule and erasing the manual safety margins of the past to maximize a quarterly return. But they do not understand that the shock wave does not look at your investment targets, and the gas pressure does not care about your promotion timeline. Every commercial empire, every infrastructure fortune, and every family dynamic is ultimately subject to the physical limits of the material below. My nephew thought he was optimizing a slow asset when he tried to clear away my experience and force me out of the control station. He didn't have the functional capacity to understand that the old, quiet man he viewed as an operational bottleneck was the only structural anchor keeping his entire complex from being torn apart by the weight of the compressed air column. In the end, he wasn't defeated by a family feud or an elaborate legal conspiracy. He was simply broken by the unyielding laws of the critical aerodynamic choking threshold he refused to believe was real.